Hi everyone, and welcome to another edition of the Code Remix Weekly. With you, as always, we are your hosts. My name is Tim Tebuk, and with me is Sam Snyder.
Hello, everyone.
And today we're going to take you, as always, through some of the things new this week in OpenRewrite Modern, and then dive deeper into a particular topic. This week, looking at Gradle upgrade recipes. But like I said, we'll take you through some of the things that are new this week. For that, I'm going to take you through a quick succession of some tabs that I've prepared. The first one being that we did a new patch release of the Rewrite Maven plugin, which, as you know, we do releases every 2 weeks on a Wednesday, usually just ahead of this call. But this is an odd week, so we didn't do a release this week, but we did have a patch release with a new feature that we are trying out, where in the past, if there was a problem parsing your Maven POM file, we would try to continue as best we could, and then in the end up with maybe a situation where your recipes weren't making the changes that you had hoped or expected. So what we've done now is we've pulled forward those issues, so you might be seeing some problems that you didn't see before, just because we're now informing you of problems that might affect the stability of the recipe runs that you might be doing at a later stage. So try out.
The motivation here came substantially from people parsing their Maven projects, ending up with dependency resolution failures, but maybe not noticing or not investigating that warning, and then running recipes which should update dependencies or do other things with the Maven builds and being disappointed and surprised that they did not have their intended effect. So we decided that it would be better overall to fail fast rather than continue in a degraded state, at least in this particular and essential component of having a well-formed LST. If you disagree with that decision or don't like it, let us know. We're happy to hear your feedback about this in the OpenRewrite community Slack. But we think that long term, this will lead to more reliable builds and recipe runs.
Yes, absolutely. So it's available already as a batch release, and we're, as always, available within the OpenRewrite Slack to offer any support that you might need following this change. But know that it is very much intentional, and it should help the stability of your recipe runs. Now, another new release that we did this week is of the Modern IntelliJ plugin that we have. And with this release, you'll be able to now generate new recipes for XML files as well. So if you click on any tag, you can generate a recipe to find particularly that tag within your project, which is very helpful. And it's available for the 0.8.0 release. There's some more release notes out there as well. So there's quite a few fixes that we've made it into this release. We've now also made it possible to debug scanning recipes or the refaster style generated recipes directly from the plugin. And we also support the very latest IntelliJ release, which is also very helpful if you already were keen to upgrade, but couldn't because of the IntelliJ plugin release that we did. So be sure to check that out. It's the latest version is available here, and you will get an update in your IDE if you already had the plugin before. So that's quite helpful.
As a reminder, the Modern IDE plugin requires the Modern CLI to be configured and licensed appropriately in order to perform most of its functions. The Modern CLI, of course, is free for open source projects, and we're happy to give out free trials and such for closed source projects. If you are interested in trying it out, let us know.
Absolutely, and I find it really helps build out the recipes that you want to write, because you can immediately jump into a pre-built model of a real project to be able to see, look around, like, well, what elements of the LST are there, or are there maybe dangling references? If you're wondering why an import isn't cleaned up, all of those things become a lot clearer when you're able to look around from a debug started through the IDE, rather than having to try to work everything into a unit test. So be sure to check it out. I shared the link in the chat as well. And then next thing that's new is that we have, but it's not yet released, is that we did some upgrades to the rewrite Java dependencies recipes. Sam, in particular, you've been quite active here, as you can see from the commits.
Yeah. So, it's part of kind of the general subject of discussing Gradle and dependency management today, but these are not only applicable to Gradle. But this find and fix vulnerable dependencies recipe, which I'll actually be demonstrating a little bit later, in case you haven't already seen it. It goes and compares your dependencies to the GitHub Security Advisory database, and suggest dependency upgrades for patch versions. And so I've fixed several bugs with this recipe and enhanced its ability, or rather enhanced all Gradle dependency management recipes abilities to operate on Gradle script plugins, which are a common place where someone might try to be dry about dependency declarations, which previously the dependency upgrade recipes were not able to address, and now they can. So along with several other fixes, this recipe should be showing you more and more useful information and dependency upgrades than ever.
Yes, very much appreciated. It's great to have these recipes to make a change at one point and then see that cascade, such that all recipes are now able to apply those same upgrades across different files that you didn't see before. So really good to have that in. Now, a new thing that's new this week, as of yesterday, we've announced it previously, but Mike was part of a Gitbook and Modern webinar, going into depth on how we write our docs and what steps we've been able to automate over the years, and getting those new versions of the documentation out there, how we version those, how we spell check all of them. And it's just a deeper dive into all the aspects that make the modern and OpenRewrite docs as best as can be. As you've probably noticed when you go through, quite frequently we get compliments on how well the docs are structured, all thanks due to Mike and the automations we have set up over the years. So if you want to know more about that, I'll share the link in the chat here as well. So you can go read that or watch that webinar and see how you could maybe do the same if that fits your flow over there. Then looking ahead, we of course next week will be at the DPE Summit, where Sam will be presenting together with Brian Demers. I think on something similar to what we will be showing today.
Yeah, maybe a slightly more refined version of today's live stream, and it did schedule this topic with the idea that it could be some practice for me.
Mm-hmm. Yeah, perfect. So you've seen it here first, and then next week you'll be able to watch it in San Francisco. And then, looking forward to that.
I'll look forward to meeting some of you in person there, perhaps.
Mm-hmm. I know we have some folks that I've only met through the open source Slack who I know are going to be at DPE Summit. So I hope you'll be able to meet them and we'll work together from there.
Yeah. If you're in the open source community Slack and you meet me in person, please introduce yourself. Maybe carry a picture of your Slack profile image so that I'll recognize you.
I've had it in the past where folks introduce themselves, and only when they shared their GitHub username that they picked a decade ago did I actually recognize them. It's always good fun. Then also next week, but on Thursday, there's going to be a meetup in Montreal. If you're looking to learn more about how you can upgrade using OpenRewrite in French, then you can listen to our colleague Justine present on that topic at the St. Laurent Boulevard, Suite 700, Montreal. So be sure to check that out if you're in the area. And then last but not least, we also have, of course, the O'Reilly book is out. So if you want to download that one, we have a form that you can fill out and then get all the latest updates on our views on how you can reliably use AI to make code changes at a large scale through, of course, the software that we help develop here at Modern and work from there. So that's it in terms of upgrades for this week. So with that, let's move over to the main topic for today. And for that, I think, Sam, you're going to take it away.
Yeah, thanks, Tim. So today I figured we would discuss dependency management. It is something that all modern software projects have to deal with in some capacity. These days you would never make a program of any particular scale or complexity without relying on the rich ecosystem of open source libraries, platforms, build tools, and such that are out there. And with that, with all of that functionality comes the reality of having to manage that essentially software supply chain, where if a significant fraction of your software, by weight, as it were, is coming from outside your development house, then you are subject to disruptions from that supply chain. Things like new vulnerabilities being discovered, or new breaking changes coming out, and it is some of these kind of pain points with dependencies in particular that were part of the genesis of the whole Open Rewrite project, part of the motivation for it. And so today I thought I would go over some of these subjects for Gradle in particular. Although much of what I'm saying is is applicable to Maven as well. Uh, and Bazel and other build systems. But I wanted to talk about Gradle not only because the DPE Summit is going up, but because there are some unique considerations when authoring recipes that manipulate Gradle source files that you don't necessarily have with Maven, since Gradle build configurations are code. They're written in Groovy or Kotlin, and you have to when writing a recipe, take into account the vast flexibility that format offers you in order to write a recipe that can most of the time successfully operate on the sheer variety that can be encountered within Gradle scripts. So I'll go ahead and share my screen, and we'll just go through some of the popular recipes in kind of the first half to kind of show you some of the ways automation can make running your Gradle build, or, keeping your Gradle build up to date and in good health easier. And then in the kind of the back half, we'll discuss uh, some of the relevant bits of API and coding patterns for when one is authoring a recipe that manipulates Gradle scripts. So to start with, kind of the if this wasn't the very first Gradle recipe we created, it was probably the second. But the classic upgrade Gradle dependency versions recipe, where when you're writing a migration recipe for Spring or something, and you need to update some dependency versions, this is the recipe that will do it. And this recipe, if you haven't checked in a while, is one that we have recently enhanced to be able to update dependencies that are in Gradle script plugins. So if you've tried this recipe before and been frustrated that it did not update dependencies that you had declared in a script, give it another shot, and it might do a bit better this time. So anyway, so in here you can fill in the group artifact version coordinates of the dependency, or if you use wildcards like I am here, dependencies that you want it to update. And my co-host Astra has decided to join us and investigate my desk. So let's give this a run and just take a look at some of the results. I'm gonna kick that off, and you see here, I've asked it to update, the popular version of or the popular serialization libraries Jackson, based on the group ID, and you're using a wildcard character for the artifact ID. And I'm saying, hey, for all dependencies that match these coordinates, that match these patterns, go ahead and just upgrade those to the latest patch version. In this latest .patch version selector, it's not new, but we didn't always have it. So even if you've been following Rewrite for a long time, you might not have noticed when it got introduced. But the effect here is saying keep the major and minor versions the same, but if there's a newer patch version available, go ahead and upgrade to the latest patch. And assuming the dependencies and projects you're using are following the conventions of semantic versioning, this should be a pretty safe thing to do because the library authors are asserting by that patch version there's no breaking changes in it. So if we pop into some of these guys, we see that I'd filled in a star for the artifact ID, but it was that star via glob pattern matching or being a wildcard character. match Jackson data bind, and just like I described, the behavior of the latest.patch version selector bumped, kept the 2.8 the same, but found that there was a slightly newer version of Jackson data bind here to use, and bumped those up. And already looking at this, just this one result, we can conveniently see the first of many ways that Gradle dependency declarations can differ. There can be a map notation for declaring your dependency, as well as a string notation for declaring your dependency. So any recipes which manipulate dependencies in Gradle have to be aware of those different formats. And we'll in a little bit later see the code that actually handles that.
Yeah.
So cool.
I
So let's
think
upgrade. Oh, go ahead.
I think we even have a recipe to standardize on one particular of these forms.
We do. There is if you found a mixture of those forms and you say want to use, I haven't run this recipe in a while, but let's see, where is it? Yeah, use string notation for Gradle dependency declarations. This is my preferred way of declaring Gradle dependencies, to use the string rather than the map notation. There is this recipe which will convert the map notation into the string notation. And if you prefer it the other way, and that's totally fine, there is a recipe to go the other way. So yeah, you can see already that there was in this source file there was a mixture of styles of dependency declaration. And so if that rankles you and you like the idea of standardizing your code format, not just in your code, but in the code that runs your build, you might appreciate using one of those recipes as well to standardize. Let's see. So kind of next up, we'd talked earlier about find and fix vulnerable dependencies. And this recipe has substantially benefited from the various enhancements that we've been making to Gradle and to the various dependency management functionalities. And this guy, like I said earlier, will try to update your dependency versions similar to a latest.patch upgrade, or it'll try to bump the patch version you're using if bumping a patch version will get you from a vulnerable version of a dependency according to the database to a non-vulnerable version of the dependency. So this is a very popular recipe, and there's a couple options you can use to tune how aggressive it is. In particular, I want to draw your attention to this override transitives flag, which will allow it will instruct the recipe to manage the versions not just of direct dependency declarations, but also transitive dependencies. And if we go and pop into the results over here, I think we will see some. Yeah, here we go. So this is if the Spring dependency management plugin is in use, it'll use the resolution strategy mechanism in order to manage the version of transitive dependencies. Speaking again to the complexity of operating in a Gradle build environment, there is a popular plugin, the Spring dependency management plugin, which will come bundled with like the Spring Boot plugin, which kind of takes over Gradle dependency resolution and tries to make it work more like Maven dependency resolution does. And as a consequence of that, one of the mechanisms that we would otherwise use to manage the version of transitive dependencies does not work. And let me see if I can go find an example of that one. Yeah, here we go. So normally, if no Spring dependency management plugin is in use, the recipe will use the constraints mechanism to manage the version of transitive dependencies. And this is perhaps a gentler way of managing the dependency version. The version you specify in a constraints block can be superseded, right? If something else says, use a newer version of JSON than 2.8.9, this the constraint as specified here won't prevent that from happening. Whereas when you do this resolution strategy thing, this overrides all other version selection mechanisms that are possible. So it's a slightly bigger hammer, and which is why we try to reserve it for situations like the Spring Dependency Management plugin being in use. So, kind of already in talking about the declarations of Gradle dependencies, just talking about the complexity of the problem space there is, the dependency could be in map notation or string notation. map notation, string notation. If it's a transitive dependency, and this version could be managed by the resolution strategy mechanism, could be managed by a constraint. It could be declared explicitly in the build file. So even without getting into plugins or scripts or other things that change dependency versions, we're already up to like 5 or 6 different ways that dependency versions in Gradle can be declared.
And of course, we've already had requests to add support for TOML files, which are another way you can do this. It's just
a couple ways that our recipes don't handle, or I haven't. I would be surprised if they handled correctly. If you have like a build source directory and you set up the plugins or the class path for your main build in there, the recipes are probably not. I'm not sure what would happen. I haven't tried that recently. If you're using precompiled, Kotlin script plugins, well, we don't support Kotlin scripts, so that's right out. So there are, even though we've covered 5 or 6, and the recipes cover these 5 or 6 ways, there's another 5 or 6 ways you could do your dependencies that to make this a little harder. So in general, the more your dependency files or the more your build is like code, the harder it is to automate updates for it. And the more you keep your dependency files dumb or declarative, the more you make them like a data format and less like code, the easier it is to automate those manipulations and those upgrades. And yeah, so since we're talking about find and fix vulnerable dependencies and the hoops it's got to jump through to get this stuff done, it'll list the CVE numbers here that are fixed by this version upgrade in the because field, and you see that sometimes even just a patch version upgrade could potentially address many different CVE numbers. And it was oh wow, this really scrolls far to the right. I wonder if I should update the recipe to put in some line breaks if there end up being quite a lot of CVEs addressed in it. When I was so this was a recent enhancement to the recipe to list all the CVE numbers, not just one of the most recent ones. And so that does get kind of long. In the test cases I was working on while developing this, there were only like 3 or 4 tops on the dependencies I happen to be testing it on. So I'm like, yeah, that looks great. And we'll see. But when there's 20 or 30, maybe I should just cut it off at some point. Maybe just end with an ellipses if it's going too far. I don't know. Let me know what you think if you have an opinion there. And
it sure shows the value of upgrading just that patch version only. Yeah.
Absolutely true. Absolutely true. You can address quite a lot of dependency vulnerabilities with just patch version upgrades, which are generally fairly safe, fairly unlikely to include breaking changes. Although if I was going to be a real stickler about semantic versioning, I might point out that change we made to the Maven plugin that we talked about earlier, which increased the severity of a particular kind of failure from a warning to an outright error, that probably shouldn't have been a patch release. If I'm being honest, you could look at that and call that a breaking change, but people are, I hope, more forgiving about that kind of thing in an application than in a library, since it's not like anyone aside from us is using the Maven plugin like a library. And yeah,
you're getting the same warning. It's just you get it earlier. That's just
That's a. I'm gonna hire you as my lawyer, Tim, if I ever need one, because that's an excellent argument. That it's not that it's not that the failure changed; it's the presentation of the failure changed. So yeah, so the find and fix vulnerable dependencies recipe will list in the data table it produces all of the information it found from the full set of direct and transitive dependencies around what dependencies these projects have that are known to have vulnerabilities associated with them, and it is in those cases where it is just a patch version away that we attempt the version upgrade. But I've been considering augmenting this recipe with an option to accept higher levels of risk, like an option where you could say, yeah, go for minor version bumps. I'm feeling lucky. Yeah, just upgrade everything that's vulnerable, and I'll deal with the compilation errors or code changes thereafter. So if that sounds useful to you, if you're like, yeah, I want to upgrade everything, let's do it. let me know, and I can prioritize adding that functionality to this recipe. Okay, so that's kind of the find and fix vulnerable dependencies, and we talked about the transitive dependency versions. There's also your Gradle wrapper, and we have a prominent contributor of Gradle recipes in our open source community, Shannon, who is usually the way we find out that a new version of Gradle has been released. I don't know if he's just if he's got an RSS feed or has some alert, but usually often within minutes of a new Gradle release going live, all of the projects in OpenRewrite in OpenRewrite org are getting updated to the latest Gradle wrapper because Shannon will immediately run it to bump us up to the latest Gradle version. And the Gradle wrapper, for anyone who's not familiar, is a set of scripts and binary files which encodes what version of Gradle the project should be built with into the repository, so that anyone who comes to that repository, whether you're using Gradle 8 or Gradle 4, whatever you have installed on your machine, when you go to build that repository, the shell script will run and it will use the appropriate version of Gradle for that repository. This is a really useful thing that is strongly recommended by Gradle and by me, that if you use Gradle, you should use it. And Maven has actually adapted this concept as well, although it's less common in that ecosystem. So if you're a Maven user, I also recommend you use the Maven wrapper. But once you have these wrapper scripts in your repositories, well, just like any other configuration as code kind of scenario, if you have 1,000 repositories, they end up drifting all over the place, unless you have some automation.
I think we lost Sam briefly there. So to finish your sentence, unless you have some automation to help you upgrade those at a large scale, you're just going to see them fall behind.
Still good? Yeah. It seems like the stream was struggling for a second, or maybe my connectivity to the stream was struggling for a second, but it seems like we're back.
We got there. Yep.
Cool. So automation can help keep your Gradle wrapper up to date, and that can be a big help. And when you have this automation, with whether it's your dependencies, your Gradle wrapper, your configuration as code, the more you kind of keep yourself current, the easier it is to stay current. Because if you're kind of like eating your vegetables, if on a regular basis you are dealing with the little breaking changes that pop up between minor or patch versions, then when a major version comes out, the only thing you have to deal with is like the new breaking changes in that, not all the breaking changes there and all the breaking changes, all the changes that led up to it. So the more you use automation to keep up to date, the easier it is to stay up to date and not to fall behind. And let's see, I don't have time to demo every Gradle recipe that we have today, but there's some others for like removing an enabled Gradle feature preview. How do we use Modern Open? So we got this question: how can we use Modern OpenRewrite Recipes for private GitHub repo? Is that paid? And so all of the parsing technology and all of the recipes are free and open source in Apache 2 license, so they're available for commercial use. And so if you want to run some of the recipes I've been showing you today for a private GitHub repo, well, like I said, you can get a trial for the CLI, and that's probably the best way of running recipes locally on multiple repositories. But there are also the open source plugins. OpenRewrite Gradle plugin, which has documentation, or which we document here, if this website feels like loading.
I think the Gitbook has some slight issues today, so it's.
It seems like that might be the case. I wonder if Mike talked with them about that during their live stream. I'll have to go back and watch it. But whether or not okay, well, it's annoying that the Gitbook isn't loading, but the relevant information is inside of all of our documentation. Like the rest of the stuff in OpenRewrite is public on GitHub under Rewrite Docs. So let's see if we in the running recipes section, this getting started guide. Even if Gitbook isn't loading to make this look really pretty, at least all of the content is there, and you can check it out. So here's the information on how to on how to use the OpenRewrite Gradle plugin to run recipes. And I will say for things like doing dependency upgrades and Gradle wrapper updates, it is I think substantially easier or more valuable if you can run them across multiple repositories. Since like if to use the open source Gradle plugin or Maven plugin, kind of one of their limitations is that they operate on one repository at a time.
Mhm.
And if you're going into each repository to add the plugin configuration, activate and run the recipe, well, that doesn't necessarily save you a whole lot of time from cloning every repository, going in there, and running the Gradle wrapper update. So these recipes in particular, I do find to be most valuable when running in a multi-repository context. So let's see. Oh, go ahead, Tim.
One of the things you can uniquely do with the platform is that we have the Dev Center, which we also have specific for some Gradle projects.
We have that set up for the OpenRewrite.org.
Yeah, or for the Gradle one, then you can see the spread of versions of the Gradle wrapper that they have over there, since they don't have Shannon helping them out. So here you can see in the center. This also works. So here you can see all the detailed versions of the Gradle wrapper that are in use across the Gradle, the 30 projects that we have ingested from Gradle.
Yeah,
if you go back to the Dev Center, then we also have a pie chart to see where they stand in that adoption. So on the left here, you can see that most of them are on the 8 something version of the Gradle wrapper. And some of them are still on 5 or 6 or 7 and working their way up to it. So that kind of insight is unique to the platform, and running that upgrade on the blue button that you see is going to help you upgrade all of those projects to the latest version.
Yeah, this will go and run that update Gradle wrapper recipe that I showed you earlier, and it is always fun to, like, if you go look at the Spring org and look for deprecated Spring features in use, these kind of large code search tools can let you find some amusing things. And I will point out, before you go and razz Gradle too much about having old versions of their own products still in use, it makes sense to have some old versions around, for testing or for documentation. Surely some of these repositories are related to backwards compatibility, so they will probably never be all on the latest version, but surely some of these could be bumped to Gradle 8.8 were they to run the update Gradle wrapper recipe themselves. So we've already gone for a while, so I probably don't want to spend too much time going in depth on recipe authoring for Gradle. So I'll just kind of touch on some of the utilities that often come up when authoring Gradle recipes. So this is the source code for upgrade Gradle dependency version. The first recipe that I demonstrated, kind of one of the original recipes for dependency management, as this is one of the most common sort of utilities that you have. And this guy is in order to upgrade Gradle dependencies found in script plugins or in Gradle.properties files or eventually in TOML files. This is a scanning recipe, which if you are if you're already a recipe author or a regular viewer of Code Remix Weekly, you probably already know is a recipe that can look through all of the files in a project or in a repository before making any edits to any of them. So you can gather information from throughout the repository to base your decisions on. And early on, you'll notice that the visitors in use are Groovy visitors. Since .gradle files are written in Groovy script, you'll use a Groovy visitor if you want to manipulate them programmatically. And at the beginning of almost every Groovy visitor that deals with the Gradle file, you will see something usually inside a visit compilation unit, because that's where it's attached, the Gradle project marker being grabbed. In Maven land, we have the Maven resolution result marker. the Maven resolution result marker contains a model of the dependencies that were requested and the repositories that were in use, and all of this kind of useful information, additional metadata on top of the text of the source file itself. And in Gradle land, the Gradle project marker has that information. And so this just has some metadata, the group artifact version coordinates of the project in question. If it's a multi-project build, the path, a list of the Gradle plugins, a list of the Maven repositories. Note, if you have a Gradle build that uses Ivy repositories, we don't support that format, so sorry, that will not be represented here, and we will struggle to resolve. OpenRewrite does not actually have the capability of resolving dependencies from Ivy repositories, because that's pretty uncommon these days. But if you do use Ivy repositories and that's an issue for you, well, that's always something we could implement. And then the kind of the meat of this marker is in this map of string to Gradle dependency configuration. If you're familiar with Gradle dependency resolution, you probably already know that a configuration is a name for the object in the Gradle API into which you put requested dependencies and then is resolved into an actual set of resolved and downloaded dependencies. And there's various configurations that have inheritance relationships with each other, like implementation or compile class path or what have you. And so in this marker, you can look up a dependency configuration by name with this name to configuration function. And crucially, when you're writing tests for recipes that use Gradle, you will need to use this with tooling API function in the before recipe spec. And what this function does is it'll actually go and run a Gradle build based upon the build.gradle files that your test spec specifies. It'll actually go write this out to disk somewhere, invoke Gradle on it, use an initialization script to add a plugin to the build, which allows us to extract the dependency information and construct the Gradle project marker. Kind of emulates the process that happens inside of the OpenRewrite Gradle plugin via the tooling API, so that unit tests for recipes can have access to the Gradle project marker. And this is, as you might infer, a somewhat expensive operation. So that's why it's opt-in. And we might make it at some point so that using this build.gradle function would do it automatically, because it used to be that we had more Gradle recipes that did not depend on this information, but now virtually all of them do. So it might be sensible to just start assuming it by default. But one kind of note about this is that in the implementation here, it will try to reach out to like services.gradle.org for like the Gradle wrapper. And it may try to resolve dependencies of that initialization script from like Maven Central and Sonatype Nexus. And so if you're in a corporate environment where access to those repositories is blocked, then there are other overloads of with tooling API that are not super user friendly, if I'm being honest, where you can provide a string for an alternate init script that will work in your environment. So that's a very low level sort of thing to do, because this init script has lots of it has to do something very specific. So yeah, it's a bit of a challenge. So if you are developing Gradle recipes in a corporate environment where you have those constraints, let us know. We can help you out with that. Yeah.
And quite recently, I think we also caught the error that would occur if you run into such limitations, and then make it transparently skip the test rather than fail the test.
Yeah, I think the failure mode changed there a little bit. So let's see. And so then in the implementation of a recipe which manipulates Gradle files, particularly Gradle dependencies, most things in a Groovy script are method invocations. I mean, obviously, like an if statement isn't a method invocation or anything, but like repositories is a method invocation. Maven Central is a method invocation. Dependencies is a method invocation. Compile only, like these are all method invocations. And it's just that Groovy kind of kind of similar to Kotlin and some other languages, has a syntax where a lambda, or as Groovy likes to call it, a closure, as the last parameter to a method, is allowed to escape or elide the parentheses which would normally contain it. And so, the way I've changed this is identical to omitting these parentheses. But when you do this, you can see maybe more obviously that this is a method invocation. You even see it here, how in this particular test, compile only omits the parentheses around its arguments, but runtime only has them. So most things in Groovy scripts are method invocations. And also, since Groovy scripts are dynamically typed, you won't always have static type information available. If you're used to operating in the Java ecosystem where you're always going to have basically 100% type attribution, except for Lombok. Sorry, we don't quite support Lombok very well yet. But you'll usually, asterisk, be able to have full type information. You can't always rely on that being there in the Groovy space. So utilities like Method Matcher that you're used to that operate on that type information can be less reliable in this context. And you may find yourself using heuristics of like, if I'm in a method whose name is dependencies and whose argument is a closure, I'm probably in a Gradle dependencies block. So, we'll proceed under that assumption. And so yeah, those heuristics can be wrong. And so yeah, so the and so you see here that in visit method invocation, it narrows things down. So like, am I looking at something that's a dependency? And then it starts checking, am I looking at a dependency which has the map notation or the string notation, and handles all of the details of figuring out the group artifact version coordinates for those two different things. And then once it's figured them out, it's going to use this utility called dependency version selector to help look up. This is an abstraction which wraps the lookup of those dynamic dependency version selectors like latest.release or latest.patch or 1.0.x or what have you, so that you don't have to, in a recipe that needs to look up what version of dependencies are available, re-implement support for that. So if you're doing version lookups within a recipe, check out dependency version selector. And then, that will figure out what versions are available based on the provided selector and choose an appropriate one. Yeah. And so all of this was still actually in the scanning phase of just figuring out across this whole build what dependencies were in use. And the actual edits come down here in the edit phase, where because this version of this recipe supports updating versions in a Gradle.properties file or in a build.gradle or in a standalone Gradle script plugin, the visitor which edits will dispatch between the properties visitor and the Groovy updating visitor. And this is kind of a general purpose sort of thing you can do when you have a recipe that you want to address multiple different types of source files. Well, return a tree visitor, which is the root of the visitor inheritance hierarchy, and have it dispatch to an appropriate language specific visitor depending upon the type of file that it is looking at. So you'll see this pattern not only in Gradle recipes, but in any recipe which has to address multiple kinds of source files. So as a recipe author, that's a useful trick to be aware of and have in your back pocket. And then I don't think we need to go line by line in this recipe, since you can leave that as an exercise to the reader, as we're already kind of approaching the 45-minute mark. But I hope that you have found this kind of introduction to Gradle dependency management recipes, both their use and their authoring, to be interesting and valuable to you. And I look forward to all of us as an industry getting towards a culture and a practice of kind of zero delay dependency upgrades. If everyone's always on the latest version of everything, well, we all have to spend less of our time dealing with supporting old versions and backporting fixes and doing old releases. And there's fewer vulnerabilities as a whole in the ecosystem if everyone is up to date. So fewer exploits and hacks and data breaches. And wouldn't that be nice? So yeah, do Start using these recipes. Start when you put out a new version of one of your libraries to your consumers. Consider including an upgrade recipe as part of that that they can run to get up to date. Anyway, yeah, that's kind of what I have to say on the subject. Thanks so much for listening, everyone who has.
Yeah, thanks very much for joining us. Then, if you want to see Sam next week in San Francisco, then be sure to check out DPE Summit. And then we'll be back with a different topic next week, and then hope to see you all then. So, thanks for tuning in, and see you soon. Cheers.
Thanks a lot, everyone.